Here we are factoring polynomials, and notice that we have two binomial here, and so we want to be thinking difference of squares or sum of cubes or difference of cubes. We notice we have a lead coefficient here of negative, so we want to make that a positive. So we can either multiply the whole thing by -1, this side times -1 and the 0 times -1, or we can just rewrite it as 625 minus 16 n to the fourth. And if we look at this, and we have an even coefficient here, so we want to be thinking difference of squares. So the square root of 625 is equal to 25, and 16 n to the fourth, if we take the square root of that, we get 4n squared. And so when we have square root, so the difference of squares, we have 25, and then we have the 4n squared, and then 25, and then the 4n squared, and we have a conjugate pair, so we have a plus and a minus, and then we know that we have the minus, we have difference of squares again, so the square root of 25 is equal to 5, and the square root of 4n squared is equal to 2n. So we have 25 plus 4n squared times 5 minus 2n times 5 plus 2n. If we solve these for our zero product property, for these two here, we say 5 minus 2n equals 0. So we subtract 5. We get negative 2n is equal to negative 5. Divide by negative 2, and we get n is equal to 5 over 2. Then we say 5 plus 2n is equal to 0. So we subtract 5, and we get 2n is equal to negative 5. Divide by 2, and we get n is equal to negative 5 over 2. And now we have our last part over here, our last binomial. 25 plus 4n squared is equal to 0. So subtract 25. And then we get 4n squared is equal to negative 25. And then we divide by 4. And then we get n squared is equal to negative 25 over 4. So we take the square root of both sides. Anytime we take the square root, we have to have the plus or minus. And then we get the square root of 25 over the square root of 4 over this, or times the square root of negative 1. And so we get n is equal to plus the square root of 25 is 5. The square root of 4 is 2. And then we also have the negative version of that, negative 5 over 2i. So then we have 5 halves, negative 5 halves, 5 halves I, and negative 5 halves I.